Today we're going to be looking at converting recurring decimals. A recurring decimal only occurs when decimals repeat forever. An example would be 0.6, meaning it is actually 0.6666 and it goes on forever. So we denote recurring decimals by dot notation. So the dot above the number means the number will recur. Here the dot is above the 7, so we can write this as 0.2777 and it carries on going. Here we have the dots above 3 and 5, which means it will recur as 0.353535. And here we have the dots between 2 and 1, which means everything between the two dots will recur, meaning this is 0.2461, 2461, and so on. For higher GCSE, you need to be able to convert fractions to decimals and convert decimals to fractions. So let's have a look at converting fractions to decimals. In this question, it's asking us to convert 5/6 to a recurring decimal. So what we have to do, we're going to use short division. So we'll write 6 and 5. Now how many times does 6 go into 5? 0 times, add a decimal place and add a 0. How many times does 6 go into 50? Well, 6 times 8 is 48. So we can just write 8 with a remainder of 2. How many times does 6 go into 20? 3 times with a remainder of 2. How many times does 6 go into 20? 3 times with a remainder of 2. And as we can see, the 3 will continue to recur. So our answer is 0.83 recurring. Now let's look at converting decimals to fractions. Here we have to convert 0.1 recurring to a fraction. Let's let x equals 0.1 recurring. Now if we multiply this by 10, we'll get 10x is equal to 1.1 recurring. Now, if I wrote the recurrings out fully, and I had 1.11111 and 0.11111, we can see that if we subtracted these two, the recurrings would cancel and we would just be left with 1 minus 0. So if we let this be equation 1 and this equation 2, and we did 1 minus 2, we would get 9x is equal to 1. Divide 9 by both sides, so we get x is equal to 1/9. So we have to note that if two digits recur, we have to multiply by 100, so the recurring digits appear after the decimal point, and likewise if there are 3 digits, we multiply by 1,000. So let's have a look at another example. We have to show that 0.18 is equal to 2/11. So if we let x is equal to 0.18 recurring, now we can multiply by 100 to get 18.18 recurring. Now we can subtract x from 100x to get 99x, and 18 minus 0 is equal to 18. Now we can divide both sides by 99, so x is equal to 18 over 99. We know 9 is a factor of both 18 and 99. So 18 divided by 9 is 2, and 99 divided by 9 is 11. So that shows that 0.18 recurring is equal to 2/11. Now let's have a look at a harder example. We have to show that 0.28 recurring is equal to 13 over 45. So let's let x equals 0.28 recurring. We want just the decimal place on the right hand side. To do that, we'll multiply both sides by 10. So we have 2.8 recurring. But now we need to manipulate this equation so that we have a larger sum to subtract 2.8 from. To do this, we can multiply by 1,000. So 1,000x is equal, so if we multiply 1,000, we'll go 1, 2, 3. So we see that we get 288.8 recurring. Now we can subtract 10x from 1000x to get 990x is equal to, well, 288 minus 2 is just 286, and the recurring parts will cancel. Divide both sides by 990, 286 divided by 990. And this simplifies down to 13 over 45. So how we can check this, we can divide both sides by 2. So the top will divide into 143, and the bottom will divide into 495. Both numerator and denominator are divisible by 11. So if we did 143 divided by 11, 11 goes into 1 0 times, 11 goes into 14 once, remainder 3, and 11 goes into 33 3 times. 495 divided by 11, 11 goes into 4 0 times, 11 goes into 49 4 times with a remainder of 5, and 11 goes into 55 5 times. So we see that this simplifies down to 13 over 45, just as required. So in summary, a recurring decimal repeats forever. An example would be 0.6, meaning it is 0.666, and so on. We use dot notation to denote which part of the decimal is recurring, and if 2 digits recur, we multiply by 100, so the recurring digits appear after the decimal place, and likewise 3 digits we multiply by 1000. Thanks for watching.